Professor Yun's The Evolution Theory from the Viewpoint of Christianity, the thorough analysis of the descent or origin of man. Lecture 23, Chapter 15, Secondary Sexual Characters of Birds. We have in this chapter to consider why the females of many birds have not acquired the same ornaments as the male. On the other hand, both sexes of many other birds are equally or almost equally ornamented. When the sexes differ, the successive variations have generally been from the first limited in their transmission to the same sex in which they first arose. We must bear in mind, as shown in the preliminary chapter on sexual selection, that characters which are limited in their development to one sex are always latent in the other. As bright colors are of service to the males in their rivalry with other males, such colors would be selected whether or not they were transmitted exclusively to the same sex. Consequently, the females might be expected often to partake of the brightness of the males to a greater or less degree. And this occurs with a host of species. If all the successive variations were transmitted equally to both sexes, the females would be indistinguishable from the males, and this likewise occurs with many birds. If, however, dull colors were of high importance for the shape of the female during incubation, as with many ground birds, the females which varied in brightness or which received through inheritance from the males any marked accessions of brightness, would sooner or later be destroyed. But the tendency in males to continue for an indefinite period transmitting to their female offspring their own brightness would have to be eliminated by a change in the form of inheritance. And this, as shown by our previous illustration, would be extremely difficult. The more probable result of the long-continued destruction of the more brightly colored females, supposing the equal form of transmission to prevail, would be the lessening or annihilation of the bright colors of the males, owing to their continual crossing with the dull females. Consequently, these variations would be liable to be lost, and would have little influence on the characters of the race. And this will be added in accounting for the females being commonly duller colored than the males. It is also shown that variations which occur late in life are commonly transmitted to the same sex in which they first appear, whilst variations occurring early in life are apt to be transmitted to both sexes. Not that all the cases of sexually limited transmission can thus be accounted for, but in the case of birds living on the ground and commonly in need of protection of dull colors, bright tints would be far more dangerous to the young and inexperienced than to the adult males. Consequently, the males which varied in brightness whilst young would suffer much destruction and be eliminated through natural selection. On the other hand, the males which varied in this manner when nearly mature, notwithstanding that they were exposed to some additional danger, might survive and from being favored through sexual selection, would procreate their kind. As a relation often exists between the period of variation and the form of transmission, if the bright-colored young males were destroyed and the mature ones were successful in their courtship, the males alone would acquire brilliant colors and would transmit them exclusively to their male offspring. But I by no means wish to maintain that the influence of age on the form of transmission is the sole cause of the great difference in brilliance between the sexes of many birds. The long train of the peacock would have been not only inconvenient but dangerous to the peahen during the period of incubation and whilst accompanying her young. Hence, there is not the least a priori improbability in the development of her tail having been checked through natural selection. But the females of various pheasants, which apparently are exposed on their open nests to as much danger as the peahen, have tails of considerable length. The females as well as the males of the Menura superba have long tails, and they build a domed nest, which is a great anomaly in so large a bird. Naturalists have wondered how the female Menura could manage their tail during incubation. In these two latter cases, the great lengths of the tail feathers must be in some degree inconvenient to the female, and as in both species, the tail feathers of the female are somewhat shorter than those of the male. It might argue that their full development had been prevented through natural selection. But if the development of the tail of the peahen had been checked only when it became inconveniently or dangerously great, she would have retained a much longer tail than she actually possesses. It must also be borne in mind that, in accordance with this view, as soon as the tail of the peahen became dangerously long, and its development was consequently checked, she would have continually reacted on her male progeny and thus have prevented the peacock from acquiring his present magnificent train. We may therefore infer that the lengths of the tail in the peacock and its shortness in the peahen are the result of the requisite variations in the male having been from the first transmitted to the male offspring alone. Thus, in the several species, the tail of the female differs much in length, irrespectively of that of the male, and this can be accounted for, as it seems to me, with much more probability by the laws of inheritance, that is, by the successive variations having been from the first more or less closely limited in their transmission to the male sex than by the agency of natural selection, resulting from the length of a tail being more or less injurious to the females of these several species. The cases as yet given of slight and graduated differences in color between the males and females in the group, in which, as a general rule, the sexes resemble each other, all relate to species which build domed or concealed nesters, but similar gradations may likewise be observed in groups in which the sexes, as a general rule, resembles each other, but which build open nesters. Hence, we may infer that within the same group, the special colors of both sexes when they are alike, and the colors of the male when he differs slightly or even considerably from the female, have been in most cases determined by the same general cause, this being sexual selection. It is not probable, as has already been remarked, that differences in color between the sexes, when very slight, can be of service to the females as a protection, assuming, however, that they are of service. They might be thought to be cases of transition. On the other hand, the difference in color between the sexes, whether great or small, may to a large extent be explained on the principle of the successive variations acquired by the males through sexual selection, having been from the first more or less limited in their transmission to the females. A few words must be added on changes of plumage in relation to the season of the year. There can be little doubt that the elegant plumes, long pendant feathers, crests, etc. of egrets, herons, and many other birds, which are developed and retained only during the summer, serve for ornamental and nuptial purposes, though common to both sexes. The female is thus rendered more conspicuous during the period of incubation than during the winter, as, however, plumes would probably be inconvenient and certainly of no use during the winter. It is possible that the habit of molting twice in the year may have been gradually acquired through natural selection for the sake of casting off inconvenient ornaments during the winter. But this view cannot be extended to many waders whose summer and winter plumages differ very little in color. Shalom.